All right, I have got a little more done on this engine. I've basically got the cam rotational turned into a straight line with this little gadget right here. So this is what I've got going on. Let me grab it like this and give it a good spin so you can see what's happening here. So this is about 9/16 or almost 5/8 of a cam that I've got as far as travel. And if I want to lever it to more, I can, or less I can. I just figured I'd just start with, you know, just kind of shoot for whatever I could work. I could have, well, I couldn't have really got more. Well, I guess I could have, but it would have been a pretty crazy looking cam. Well, considering how I made the cam, which is just an off-center circle, you know, I think that that's pretty good. Now I welded these three pieces together really carefully. I just set them up and I squared them, and then I actually took this piece off and put it in here and clamped everything down, and then took the piece out. I didn't want to get little welding blobs in it because I used the MIG welder. So I don't have any issue with that. A little bit of grease, a little bit of heavier grease than that'll stay just in really good shape. So, you know, I'm okay with that. I guess that's good. All right, so I'm just showing you what I got going on here. There's the bit that I cut. I use a combination of a grinder and a diamond wheel to do that. I use a grinder to cut away the metal that underlays the carbide, and then I use a diamond wheel to shape it when I'm done. And you see what I've done here is I've just made a couple cuts, one for the C-clip, one for the O-ring. I've drilled it here. I drilled it on the lathe. Then I drilled this hole, not with this, but with my drill press. I could have used this, but there's just no reason. I have the drill press is quicker to use. So I'm getting ready to do the same thing here. C-clip and a O-ring there, and then I'll cut it off somewhere up in there when I'm done. But I just wanted to show you. I want to show you just how small this is, because it is. Yeah, it is. Pretty small. So that's basically 2 inches wide. This is a piece of brass, and then the shaft that I have on here is about 3 3/4 of an inch. So 2 inches wide. That's about 50 millimeters. We were in that area, a little bit over. It's actually a touch under. I just wanted to show this while it was exposed what I had done. I just welded that piece on and heavily tacked these two pieces of square together to make this little platform. I can make it, well, I can take it off of there pretty quickly too if I need to, but this is a good way to you know, to experiment with it. What I have going on here. So that's doing pretty good. It's not completely tight. That's why you're hearing it click a little bit. But it doesn't move much, as you can see. It's holding it pretty good. And these are really lightweight springs. They're not much at all. They're just kind of keeping it where it sort of wants to be anyway. Still, it's running decent. I mean, it's nice and it's free. Obviously, I've added 2 sources of friction to the flywheel, so it doesn't free run like it did. But it's still not bad. I mean, that's really quite nice. I don't think the steam will have a problem. For that matter, air or steam will have a problem of operating the engine at a low pressure. You know, maybe if I could get it to run at like 15 pounds, 10 pounds. But I really want to run it a little bit higher. I went on to my valves yesterday, and I noticed that they were really hard to turn. But now look at this. Now they're turning really easy. Let's see if they're both that easy. Yes, that is really super good, because I don't want any losses in the valves. And you may notice I've got what looks like to be a pinion gear. It's bigger than this piece. If I would have used this gear, I wouldn't have had the turn I wanted. I wanted to get about 180 degrees out of it. So I got a smaller diameter. That's probably, I'm going to say that's probably 9/16. Anyway, I put some tape on here and just marked where the gears were, you know, where the top of them were. And I put the tape on this, and then I use my grinder to just cut. I mean, just approximate. I've done this before. It works better than it would sound like it works, but that's the end of it. You can see where I've cut those gears off since. So I've got these, and they're still not quite completely shaped, but they're not too bad. I guess I should, let me get these. Yeah, something like that. Anyway, the rack is over here, and you can see that I roll on it reasonably well. To this end, what I'm going to do is I'm going to take these in, and I'm going to use some of my jeweler's tools, and I'm going to clean these up so that they work properly. They work better. And then when I'm done with that, I will weld a little cylinder to the side of them. I'll weld it to this gear itself, and I'll drill a hole in it, and I'll put a set screw in that, just a little piece. And so that's just my best solution. Quite a little bit of labor, but you know what? I have the parts. It's not a big deal. So let's see what I can get here. So these nasty little dudes I just finished doing. I think I've got a good idea of where I'm going with these anyway. So I know this looks rough, but they're actually pretty nice looking. And the idea that they just, you know, and that's funny. These were moving really nicely a few seconds ago, like that, yeah. So you can see they move pretty good on the rack. Afternoon, evening, morning. I think it's actually morning. I am kind of getting ready to put some stuff together. I've got that worked out pretty well. What did I do? I drilled a hole in this, and it's not bad. It's not perfect, but I think it's reasonable enough. That gives me the way to run it. So I need to put a set screw in it. I was going to set my valves up so that I could look down at this rack and see them, but if I do, I'm going to run out of room here. So I've changed how I want to do this. I want to actually bolt my valves onto this little upright piece here. And to that effect, I've cut a piece of angle out. Let me refer to my pointer. So I cut this piece of angle out that I plan on bolting here so that it sticks right out here, so that it's like that, you know, it's coming out this way. In order to do that, I had to cut a couple holes in yeah, anyway, yeah, it took some time to do it. And what I'm doing here is I'm getting ready to put a little block in here. This is a little 1/2" by 1/2" piece of steel, just a little scrap that I want to tack in down here, and then it's going to pull back as soon as I do that. I can't really block it in very well. I've got it sort of held with this little piece of strap, but it's not held very tightly, but that's okay. I want to go ahead and tack it here, but I have all my stuff in here. These bearings were like $8 for each bearing. There's a bearing underneath that gear that you see there, and also the same thing over here. There's a bearing underneath there, and I just don't want to get too much splash on any of that stuff, including my little gears that I made by hand. I put this together yesterday, and it's just two 1/2" 20. The thread pitch is 20 bolts or nuts. I'm sorry. That basically the same as that. Can you see that? I am just really terrible for pulling the camera down here and then moving my hand way up here and pointing out stuff and then forgetting that I did it and then having to throw the film away. Well, okay, the equivalent of throwing the film away, the digital equivalent of it. Anyway, so I've basically tacked all this stuff together to hold the top. I was able to align everything. So far, so good, knock on wood. And so I hope I can keep my alignment straight, because these really need to run well. You can see right here, that valve isn't, or that shaft isn't centered in that valve. So I'm just gonna have to drill another valve, because I can't make the shaft run properly in this valve. The valve is crooked inside. So I'll have to redo that. And I hope I have another one of these. I should have. Okay, so I chickened out. Rather than weld the bottom and then let it cool and weld the top, I hit the top first and then the bottom. I mean, really fast, so that I hopefully have contained it. I think I'll take it apart and hit the other side now. So yeah, I'll just show you. So I'll have to pull the valves out and just take everything off completely and continue. Actually, I might tack it heavier before I do that, though, because I do have, I mean, it is held in place here. But I'm going to have to get a brush out and clean all that. So yeah. Here's my finished valve assembly. You're going to focus. Going to focus. There you go. Yeah, let's just do it this way. So things are turning pretty decently here. I don't know if you can see that. So that's good. I mean, for my first fit. I have the mounting work finished on these. So it's kind of what we got going on here. Maybe it would be better to show from this angle. Here we go. So yeah. So anyway, that's what we got going on. Now the reason that nothing is really working is because I don't have any set screws or anything. Everything is just kind of setting here. But the nice thing is everything is got play in it. And of course I'm not filming it, but so that's pretty nice. These two will swing around. I imagine that I'll have one pointed one direction and one pointed the other direction, but you know, I could even do them at a bit of an angle. It just depends on the timing, because this will actually set my timing. This adjustment will set my timing. And to that end, I'll probably have some sort of set screw to hold these in place once they're where I want them. And I'm using grade 5 bolts, nuts, so I want to make sure that I can take these apart and put these together a lot of times, but that's the way to do it. So you can see that's a pretty nice and compact setup. It actually, it almost clears the entire wheel. In case I wanted to put a belt on here, I really would like to have this stuff as out of the way as possible. But we'll see. I may not be able to, and I may not need a belt on here. I got other ways to drive this. I thought it would be fun, though, to make a belt to drive a little generator. Anyway, that's the plan. So I drilled that out to a 5/32. What would that be, like 4 millimeters, something like that, 3.5 millimeters? I really don't know. Anyway, it's what it is, and because I'm using just a regular basic tap you get at the hardware store, you see the taper on this tap. Let me see if I can. There we go. So you see it's got just a real slight taper on it. So I can only go down just a tiny bit past this point. I guess I could drill all the way through, but I don't need to. So I'm tapping with this tap. That's my first tap. That's my 1032. Then I'm finishing up with another 1032 tap that I have cut the end off of, so that I can get my threads to open up. And they're still just a little bit tight, but I mean, I think that's perfect. Anyway, so I don't really need 2 set screws on here, but you know, I figure just for the sake of keeping things equal, I would rather have 2 on here. Anyway, I'll have 2 set screws there. I'll have a set screw on each one of my gears. I'll have a set screw on each one of these nuts. So I've got a lot of adjustment. And that's not to say that these valves are going to work. And that's not to say that keeping in mind that these valves are separated a little bit of distance from the engine. So I actually have a larger displacement engine, so to speak, because I can put more in my compressible area, right? Because I have all this steam under pressure coming in. Actually, the top valve is where the steam will come in. Oh yeah, I'm doing what I typically do, putting my camera underneath it. So anyway, so my cutoff is here. So everything past this point is all part of the energy that will push this piston back. So I actually have a slightly larger chamber. My only thought about that is that when I get this thing started, there's going to be water coming out of this lower end, and I put this port on the bottom so that the water would drain out. I don't want to slam this cylinder with a bunch of water in it. I mean, that's not good. It's never good for a compressor, and this is basically a compressor. So what I'm thinking about doing is I might put a little loop down here, or some way to make sure that the water that accumulates in here as this thing is warming up has a place to go. I want to make an adjustment on this rod so that I can hold the amount of distance away from the gearing. I can set that, because I noticed that if I push it back just a little bit, it quiets it down really nicely. So I've got a little roller that I've made in the past. I think I'll probably modify it and put that roller out here so that I can adjust it and just hold that, adjust that basically, so that there's an adjustment. And you're probably going to focus on everything else but that. So you can see that the valves are moving like they ought to. That's about 120 degrees of movement. That's plenty, so I think. And if I wanted to get more movement, I could use smaller, well, I could go with a different rack and smaller gears. But anyway, so I'll show you what I've got here. So I'm able to adjust the timing here and here. I can swing these around and adjust the timing, and so that's really kind of cool. And I can also reset these to any position I want and reset the shafts so that I can reset my timing. Now I put a little mark on my shaft. Let's see if, okay, that sounded bad. I put a little mark on the top of this shaft. It's a little line right there, and there's also a line right on that one. Can you see it? Anyway, just a little tiny, it's just a little line, and that's where my intake, that's where, if that line is lined up with this port, that means that that's open. The way that this little tray works, and I don't know how I would do it anyway, this tray moves faster when my crank is moving east to west. You see what I'm saying? Like east and west, or whatever. Actually, west is that way, east that way. Side to side, when the crank is in the bottom position and it moves mainly side to side, it moves quite a bit. You notice it's moving about 3/8 of an inch from here to here. However, if I move it the same distance, okay, like I'm moving that about, let's call that 45 or 90 degrees. If I go up here and I do 90 degrees and I swing that up and down, look at how little movement I've got here. Look at that. It's not even 1/8 of an inch. So I have this variable movement going on where when the crank is going mainly up and down, it's barely moving the slide, which means the valve is barely turning. The only real time the valve is really turning is when I'm going left and right. I mean, that's turning the valve, because now we actually have movement here. Like I said, about 1/2 an inch actually. So I was just in a perfect spot where, because of this effect, which I did not account for, I perfectly got the right, completely wrong number of teeth on my gears on the valve. Now, a lot of that was for convenience, because it's a whole lot more convenient to make this little gear and then weld a collar to it and then put a lock screw on it. That's pretty easy. But now, now that I have this smaller gear, I mean, I can't really do that. I'm going to actually, if I were to drill that to 1/4 of an inch, I wouldn't have much left. I don't think my gear would survive. And then if I drill, you know, I can't go that way out. So now I need to cut this down 1/8 of an inch. And then my point, or my thought, after thinking about all the ways I could do this, was, yes, make an 1/8 of an inch shaft, thread it, and then tighten the bolt up underneath it, because that way I'm holding this, the 1/8 inch shaft in tension, and I'm using this gear as a spacer between the nut and between this little shoulder of the shaft here. That holds this piece in tension. That makes it a lot stronger. My only issue is that I will need to lock that screw or lock that nut somehow so that this doesn't turn. However, I do want to be able to loosen that and turn this, because each one of these little teeth on here, by the way, they're hand cut, and some of them are pretty disgusting looking, but they work. That's like 51.2 degrees of a turn. Like if I you know, go from one tooth to the next, if I want to advance or retard it, that's the smallest amount of advance I've got is like 51 point something degrees. So I want to be able to lock it down and then move it so that I can move it halfway, not a whole step if I need to, because I'm scared that if I don't allow myself the ability to move these gears a little bit, that I'll do basically the same thing I did here. I'll weld this gear somewhere where now I'm screwed, or now I can't really adjust it well. So anyway, I do have reasonable amount of adjustment. You know, I mean, I can adjust it with, you know, by moving the valve orifice, right? I can move this damn near 90 degrees, or damn near 180 degrees. However, in real life, I'm going to have hoses connected to these, so I'd like to be able to kind of be able to keep that range, which way I move, you know, how I move this to time it. I'd like to be able to make that range so that these valves are sort of facing the engine, or facing the, facing, so my piping isn't an issue. It's a neat little setup down here. Can we get in there and just show you what it's doing? So it's working like it ought to down here. Everything seems to be working like it should be working, and that's just, yeah, don't worry about that. That's just my test stuff. Good afternoon. So I'm back down here working on this little gadget. I have had a hell of a time trying to time it, even after changing my gears from these bigger gears to these smaller gears. I do like the idea quite. Well, there are a couple things I don't like about it though. I don't know that I like this piping, because every little bit of piping is a time delay, in my opinion. And so that's one thing I don't like about it. But the thing that I really have decided I didn't like about it was the way that I set this up. Now, this is my crank shaft, and it's keyed. It's got a little key. I'm going to go ahead and keep it. This is my cam. You notice my offset. Now, you look at this and you can see that my offset is set up so that it works. I don't know if I can say this properly or not. I'm sure you can understand it. I just don't know if I can say it. So here we go. I'll see if I can just, well, let's try it this way. Yeah, it's not too bad. All right, so what I'm having issues with is I can't time that. I can't get my valves timed right because I've got too much overlap one way or another, or I don't have enough of the valve open. There's not a happy medium in there, so they're not doing what they should. I can get it I can get the valves to work weakly, but when I get the intake work, when I have them both as good as I can set them, they're fighting each other. The overlap is a problem. So here's why I think I'm having this trouble. When this is turning, I'll just go ahead and stick that here there. Okay, so when this is turning, this wheel is, this is top dead center. Yeah. This is top dead center. This is the crank. The thing that I've got, the issue that I have, is that when I'm at top dead center, and a little bit before and a little bit after, I'm basically moving vertically, right? The rod is moving vertically, so this pin will move like from in that direction to that direction, and this cam gets very little travel. However, when I'm traveling between top dead center and bottom dead center, I get into an area where the rod is moving more left and right, and my cam is moving faster. Until I get to this point, then my cam slows down again, because now the rod's moving up and down. So while the rod's moving the same amount, I mean, like say if we were to say, if this is 90 degrees from here to here, and 90 degrees from there to there, the movement of this cam is about 4 times more when the movement is, when the rod is up here, moving from this spot to this spot, rather than from this spot to this spot. As you can see, I mean, there's very little left-right movement when this thing is moving up, down, right. It makes sense. I didn't think about that. So what's happening is that I'm just going to call it dwell. I have more dwell time. I know I'm using that term wrong, but I have more dwell time here than I do here, right? Because this is where this gear is moving its fastest, when this is going from left to right. This is where this gear is moving the slowest, when we're on the top dead center or the bottom dead center. And I realized that's a big problem, because I'm trying to time this to open and close either right past top or bottom dead center. I'm right past bottom dead center. Well, actually what I want happening is I want my exhaust valve to close somewhere up here. So I want my exhaust valve close up here, or my intake, I'm sorry. I want my intake closed up here as this is rotating clockwise. When it gets down to here, I want my exhaust valve to start opening. And I want it to open, and I want it to stay open until I get to here, then I want it to be closed again. Somewhere in that area, you know, but that's kind of what I want. And the similar thing. I want my intake now to open up here, right when we get up here. And I need it to be pretty accurate. If I can't get that accuracy, I can't get my timing where I need it. And so my issue was, I have the area that needs to be most critically timed is the area right now where my valves are moving the slowest, right? That's an issue. And so I'm going to change that by moving, and I'm going to actually increase the size of my cam because I have to. But I'm going to move my cam like this. Let me just go ahead and pull this all the way out. So I'm going to move my cam so it's 90 degrees off. And if I move my cam so we're 90 degrees off, then when I'm at top dead center, okay, so here we are. I'll just go ahead and set it this way. This isn't perfect, but you'll get what I'm saying. So now, if I'm over here at top dead center, then I am in an area where my valve movement is the most. So I've got a lot more control over whether these valves open and close. Right here, much more control, like by a factor, a multiplied factor. If you notice, when I move this an inch, let's call that an inch. This actually moves almost an inch, right? That's huge. This moves I mean left and right, this moves maybe a 1/16 of an inch. So you can see that my ratio is hugely different, so I have a lot more control that way. Now maybe I'm going too far. Maybe I should set it just a little bit, you know, like maybe set it in between. But you know what, I'm gonna continue on, and I'll set it at 90 and see if I get an improvement. So that's what I'm gonna do, and I'll explain further. You'll see if I didn't explain it well, which I may not have, you'll get what I'm saying. But rather, okay, so I'm back. I've been busy doing, well, a bunch of other stuff. But I've been getting back to this. I've been playing around with the size of the gearing on the valves. And so, let's see what I can do here. There we go. So that isn't too bad. I'm getting a start on it. That was about 240 RPM. It was about 4 RPM, or 4 revolutions per second. So anyway, that's not too bad. I'm pushing some pretty high pressure in it, but I don't know that I actually need it. Or I might. So, see what the rod is doing to the metal here? It's actually pushing it over, so making the base even stronger will make for a better stroke. But it's actually, it's not. Yeah, it's working pretty well. So there's quite a bit of lubrication on here to make it operate as smoothly as it does. And that rattle that you hear is a rack and pinion running my little valves that I made. But let me run it one more time, and then I'll grab the camera and show you where I'm at with it. But we'll get one more little run out of it. Was pretty cool. The last time that I ran it, I was pulling the hose away from this to drop the air pressure, actually operating the engine, and that seemed to work pretty well. Look in the eyepiece as I'm describing things. So I'm going to try that this time around. All right, so there's the engine. I just got done running it, so it's going to look weird because I'm figuring out. Anyway, it runs pretty smoothly. It's oiled pretty well, but this is the first time that it actually ran. So I'm really happy about that. And let's see, I guess the components of it, you've seen the piston, I think. You've seen the rod. I mean, that's all been the same. It's got a 2.5-inch stroke. I set the compressed air down to 50 pounds and it was operating it just fine. It probably dropped it down to around 30 or 25 pounds when it finally started operating. So it was operating slower. My controller for the valves is this little slidey piece here, which is right there. So that's my slide piece that is connected to a push rod right there. Okay, and this is the cam. I changed the size of the cam. I didn't like the limited amount of play that I got with my original cam. I had about a half of an inch of travel total. This is double that. On top of that, I went from 9 gears. Let me just show you these gears. I went from a 9-tooth gear. Where are we at? Here we are, down to a 7-tooth gear. These are my original gears. These are handmade, so they're a little bit rough looking, but you know what? They worked. Well, okay, they really didn't work. They might work now, though, now that the cam makes more sense. So let me allow myself to introduce myself. Let's get over here and show you my valves. So they're just basic brass valves. You've probably seen how they work internally. The difference is that these, let me change hands here. These valves are also cut by hand, but I get a little bit over 360-degree rotation on these valves. So that's really good. They're still just a little bit rough. That's why I've got this vice grip behind the rack. It's just holding a block behind the rack to give them a little bit of play, but to keep them from jumping, because that will actually, they will jump. I mean, that rod has enough movement in it that if I don't have it blocked behind her with those vice grips and that little block, this rod, where are we at here? This rod, yeah. This rod will move left and right. I don't have, I mean, it's being held under the cam so that it won't get into any trouble. But back here, it's basically loose. So that's why I've got that block behind there. But so anyway, that's the action that I'm getting. These two little dots, the two little dots here, show that valve open. And you can see that valve is open in relation to that port. So when I line up those dots with that port, yeah, are we going to get it? There we go. You probably get it. I probably don't need to belabor the point. But the idea was just so that I would have at the bottom dead center and at the top dead center, I would have much more movement of my valves. So you can see my valves are really moving right there. And that's important because that allows me to adjust the on and off of my valves a lot more accurately. And I will eventually do that. But right now I've set up roughly time for compressed air. I've not tried to tinker with it to make it any better. At some point I may, I can actually advance or retard by loosening my set screw on the valve. I can advance or retard my intake timing, and I can do the same with the exhaust as it's running. But I'll worry about that down the road. That's really not too big of a deal right now. The biggest deal was making sure that it actually does operate, and it does. All my pieces are good. And you can see I just made a slide. I have got, well, I could explain that further, I guess, if somebody wants to see it. But the idea is that I have it so it's setting straight up and down, and it can't really tip. And the reason it can't tip is because I got this piece of square metal right in here, and it's sitting on a flat surface, and then there's a flat surface welded right above it so that it can't tip. I mean, there's very little clearance there. What I did was I put this together. I put a piece of paper on top of this slide, and I set this piece on top of that piece of paper and welded that with 4,000, basically gave me 4 thousandths worth of clearance. And since I finished that, I've actually tapped that down to make it just a little bit tighter. But that's I think it's an 1/8 inch piece or 3 millimeter piece of steel. Same thing over here, did the same thing, so that I have a tiny bit of play, but I have mainly a nice rigid piece, so that it's not trying to crash into this, or you can see where it could get into trouble. And believe me, it has. As I've been working on it, I've had issues with it. So anyway, All right, I'm happy. It's actually working pretty well. For a single stage engine, I'm real happy with the way that it finally is timed out. But anyway, yeah, we'll continue on. I have to go make money this week, so I'll be busy making money. Mind you, not very much, but a little bit. And so I'll get back to this. I'll think about it, think about where to go with it from here. But really, I'm almost at a point. I'll probably tune it up to see if I, to look for any of my friction points, any bad points, any of my timing, see if my timing is working good. Try to get a better feel for that. I might even strengthen this. I need to put this on a platform and then screw it down. That would strengthen it considerably. That way, when we're sitting at top dead center and I push air into it, it wouldn't actually bend it won't bend this frame like it did, like you saw it do. Anyway, and you see on my left and right, I'm just basically holding my rack in here with a spring. Well, I shouldn't call this a rack, but call this the slide. The rack is actually the thing that's running the gears. But this is basically just some banding, steel banding that I've bent to be like a bit of a spring, and so it's just holding a little bit of pressure onto these to keep this thing lined up. But keeping in mind, I have everything lined up pretty well, or else this wouldn't work. But I've just gently got it, or I have got it held gently in place. And it seems to work pretty good. So. Anyway, all right. Y'all have a good one, and I'll update you when I have something to update.